Our next speaker today is a very dear friend of mine. He's Alessandro Lai, who is a backend developer, currently employed as project lead at Facile.it in Milan. He previously was a C++ developer, and he switched to PHP, feeling the appeal of a thriving community and embracing TDD and CI/CD methodologies and all that good stuff. Thanks in particular to phpday, he started getting more involved with the open source community. So first he got involved with the development of ParaUnit, which is a project of his. And then later he became secretary of the PHP Framework Interoperation Group, also known as the PHP FIG, where we actually met. And he also is one of the organizers of the PHP User Group Milan, which we also coordinated together back in the day. Now he's presenting a topic which is very dear of his, which is Kubernetes for PHP developers.
Hi.
Hey, Alessandro.
Hi, Stefan. How are you?
I'm fine. I'm pretty good. Thank you. So I will just leave you the stage, I guess.
Thank you. Okay, so let's get ready for this talk. So hi, everyone. Stefan already introduced me very well, and so I want... oh, sorry. I think I've killed my share screen. Back in a second. Okay, here we are. Perfect. So I won't lose any time in presenting myself any further, and I will just go through with the topic of today, which is Kubernetes for PHP. Well, Stefano rightly said that it's a topic which is dear to me because I'm playing with it for the last 2 or 3 years at work, and I've enjoyed it a lot because basically I've found that PHP is a really great technology to be used on Kubernetes. And why is that? Well, basically, Kubernetes, for those of you who don't know what it is, it's an orchestrator. So basically, it's the de facto standard of deploying into containers in production. It means that it is a piece of software that will decide for you how to handle the workload on your cluster of machine when you want to deploy to multiple servers. And PHP is really a good fit for that because it has an architecture which is share nothing, so it doesn't have to have any sub-dependencies below itself in the server, and it's easy to scale just by replicating containers. The other nice thing about PHP in Kubernetes is that it requires not so much resources, so you can just spin up a web server and a PHP FPM container, and with as little as, I don't know, 128 megabytes of memory and a little CPU, you can handle a lot of workload, a lot of users on your sites, right? You probably already know that. So let's try to, I'll try to give you enough insight on this technology to avoid getting scared about jumping into this new thing. First and foremost, Kubernetes, where it came from. Well, basically, it's an open source project written by Google. And they did that because they already had a lot of knowledge on that topic. They had a C++ project called Borg that they were using for many years to deploy all over the world using containers. And so they decided to rewrite all their knowledge inside this Golang project, which is open source, and it's now become the de facto standard for this kind of technology. When we talk about Kubernetes, as I said, it's an orchestrator, so it's a piece of software that handles your application inside a cluster of machines. So when we are talking about a cluster, we need to split machines between master nodes and worker nodes. So the master nodes, well, you have at least one master node, but normally you will have at least 3 if you want to have an high availability cluster. It's basically the brain of your cluster. It's where Kubernetes resides mainly and takes decisions. Inside the master node, you will find etcd, which is a daemon to hold configuration. So it basically stores what you are telling Kubernetes to do. An API server, so a literally API server that you can use to talk to the cluster. Well, not directly, not using HTTP. We will see later how. A scheduler, which is the piece of software that takes the decisions. So it says, okay, I want to execute this many containers here and that many containers there. And the controller manager, which is basically the ARM branch of everything. So it's the piece of software that executes the decision of the scheduler. Then you have worker nodes, which is basically your fleet of machines. It's where your application will run. And worker nodes will be comprised of a kubelet, which is the other end of the controller manager. So basically the piece of software that receives commands from the controller manager. A kube proxy, which is a networking piece that basically constitutes a virtual private network inside the cluster. So every container can float inside a virtual network and don't have to care about the fact that you have as many worker nodes as you want. And a container runtime. So you can think the Docker daemon, basically. So something that is able to spin up containers for you. If you are instead using a Kubernetes cluster as a service like Google Cloud or AWS, you probably won't have to deal with master nodes, but you will get that as a service, so always available. And you will just have to spin up worker nodes and pay for that. And so you will just be limited by your budget and by how many worker nodes you want to have and how many resources you want to allocate. Remember that in those situations, you don't have to worry about the machine themselves. You don't have to, I don't know, install the operating system, update that, and stuff like that. You will just have a machine that contains Kubernetes that acts as a worker node, and that's all. It's pure resources for your cluster, nothing more. The last thing of my bullet point list is kubectl, which is a CLI tool that you can use to talk to your cluster. And I can suggest to use that to be more familiar with this kind of technology. Basically, you can just write on your console kubectl get something or describe something, and those are safe verbs in the same way as get is a safe HTTP verb for a REST API. So you can just snoop around in your example or your application deployed as you want and just try to understand what is building this application that it's running inside Kubernetes. I just suggest to you to follow up the installation instruction up to the point where it helps you to set up the autocompletion, because it's vital to use the autocompletion on kubectl. It has a lot of different commands and you have to insert the names of what you're putting inside your cluster, so it's a lot easier if you do that. But how do you put things inside your Kubernetes cluster? How do you put your application inside of that? Well, I've talked about an API server for a reason. Basically, you can draw a parallel to a REST API because the Kubernetes cluster exposes information as resources, like an API REST, a REST API that you can write yourself in PHP. So I will try to describe those resources to you so it will be clear of what you are talking about, what are the building blocks of an application inside a Kubernetes cluster. The first building block that you need to know is a pod. A pod is the minimum scalable unit inside the Kubernetes cluster. It's just a thing that it contains one or more containers. So if you have a basic PHP application, you probably will have a pod with inside an Nginx container and a PHP FPM container, and that's all. The only strange thing is that you will never create directly a pod. You will do that indirectly using, for example, a deployment. A deployment is another resource that describes your application. So it's like a blueprint. It's something that Kubernetes uses like a cookie cutter to create more pods for you. A deployment could be written down with the help of two other resources, which are config maps and secrets. Those are just key value stores. And the only difference between the two of them is that the config map is in clear text. So basically, you can use config maps to store, I don't know, Nginx configuration or stuff like that, any files, anything that you want. And secrets instead to store stuff like, I don't know, credentials, API keys, or TLS certificates. So you can use those, put inside the deployment, and use them as a placeholders for values. So your deployment is parameterized. There's another way to create a pod, which is a job. Let's say that there's a main difference between a deployment and a job. The deployment is like a daemon, so it's a way to be sure that a pod is always running. So if you want to have a web server, you describe a deployment with a web server inside. And if it crashes, the deployment will take care to restart the pod and have it always running. Instead, the job will wait for the process completion. So maybe you can use it for, I don't know, database migration, for example. So it's a replacement for SSHing into the server, for example. You no longer have a server where you can SSH into, so you can use a job to do the same things that you will probably do in that way. Another resource that works through a job is the cron job. Well, the name explains itself. So it's basically just a way to create jobs on a time schedule. Okay, with that, you should have enough resources to build an application in the same way that you have built that inside, I don't know, an EC2 server. Now you need to make that accessible from the exterior world, from the internet. The first thing that you need to do is to create a service. A service is just a placeholder to give a name to your application. So it will just work as a proxy and as a load balancer. So you don't have to care about how many pods are there, if there's a deployment rolling out in that moment. You don't have to care. You just put a name in there, target all your traffic to the service, and you're done. So now the last piece of this puzzle is the ingress. And the ingress is basically the door to the exterior world from the cluster. So an ingress will just take all the traffic from the exterior world and route it through some rules to the right service, and there you go. This is all that you need to do to know as a developer. Obviously, I will not do a deep dive on the DevOps side of things because I'm not knowledgeable enough to do that, but I hope to give you enough understanding to decide if you as a developer are interested in this kind of technology. So now that I've named all the components, I will try to show you how you can write those down, but I will try to do that in the opposite fashion. So I started inside out, and now we'll try from the outside to inside. So we'll start with an ingress. As you can see, basically, you can describe all resources of Kubernetes with YAML. Yeah, that's not great, but the upside from using YAML in this case is that kubectl or the cluster itself will try to validate this YAML before using it. So it's a bit hard to screw up in that regard. If you want, and if you use PHP Storm as your daily editor, there's a nice Kubernetes plugin that gives you validation and autocomplete on those YAMLs. So it's a good way to start and trial and error while writing those YAMLs. This YAML is all that you need to describe an ingress. It's pretty short, but you can say that basically when you try to describe a resource for Kubernetes, you will always have a couple of fields. The first is the API version. So you're saying which version of the API of Kubernetes you are using to describe. It's basically a schema. The kind is obviously the type of resources that we are describing. And then you will always metadata with the key name. The name is the ID of the resource. So you cannot have two resources of the same kind with the same name. No collisions. Then you can have labels, which are just key values as you prefer. For now, that doesn't matter much, but they will matter later. We will see that. Then you have the body of the resource with a spec, so a description of what you want to have. An ingress is just comprised by rules. So in this example, I've just created one single rule, And this rule says, okay, if you get HTTP traffic with this host name, you will route that from the full path without any rewrite to this service with this name and this port. And that's all. With that, we are giving access to our service from exterior traffic. I've also added this key TLS because it's a nice thing to have with a Kubernetes cluster, and I do that a lot at my daily job. Basically, you can put the TLS certificate at the cluster level, and you can stop caring about it. Basically, your application will receive clear traffic, and if you need, for example, I don't know, to renew the certificate, you will just change at the cluster level, and that will be handled by the cluster and the Ingress, and that's all. The Ingress will be doing TLS termination at the cluster start, and that's all. So one step down, a service. A service is still a simple resource, it's not so complicated. So still API version, kind, metadata with name, and then the spec. For the service, you just have to say which ports you are exposing on this service, in this case, port 80, and this is the name of the port, so you can reference it elsewhere if you need, by name and not by number. And then selector. This is the first time where labels matter. Basically, it's a selector by labels. You are saying each pod that matches this combination will receive traffic. So this is the only piece of those resources where labels matters, and you have to care about that. Then one step further, deployment. This is the only resource which is a bit verbose, so I've split that into slides, but it's still kind of simple. So API version, kind, metadata with a name, still the same. Then the spec, and here we have the interesting bits. Still a selector. This is a selector for deployment to the pod still, so you're saying, okay, this deployment handles all the pods that match these labels. And then in here, you have a description of how you want your deployment to act. First, replicas. So how many pods do you want for this deployment? In this case, 2. This is a nice parameter because basically just by writing here 4, you're scaling vertically without any issue. You just need to have enough worker nodes to do that. But as I said, PHP doesn't require a lot of resources, so doing that is so easy. You just have to change a number and you're done. Then you have a strategy. The strategy is the way that the Kubernetes orchestrator we use to change the pods for you when scaling or when deploying a new version of your application. So you have a type of strategy. The main two are rolling update and recreate. Recreate, we just delete everything and recreate from scratch. Is not useful for an always available application. So rolling update is the most common. And then you have 2 parameters to guide this strategy. You have max surge and max unavailable. Both can be expressed as single values or percentages, and they say 2 different things. Max surge is how many pods I can spin up in advance when I need to switch 2 versions, and max unavailable is the opposite, how many I can spin down before my application becomes unavailable. So in this case, I can spin up 2 more new pods, and I can spin down just 1 because it's 50% of 2. Okay. This means that basically every time that you say to your cluster that you want to change something, you just touch these values, you will try to roll the new pods up and replace the old one with the new ones automatically for you. Then you have the template for the pod. Still, you have labels. And second part, you just have to describe what's inside this pod. So normally just containers. And as I said, Nginx plus PHP. On Nginx, I'm saying, OK, I want to expose port 80. On PHP, I don't need to expose any port because those 2 containers are talking through localhost, basically. In this example, I also added an environment variable, which is populated, since it's a password, from a secret. So this is a way to reuse secret inside your deployment. And this is probably where it clicks for you why so many frameworks are going into this direction in using environment variables. It's easier to do that in an environment like this one, in a containerized environment. This doesn't come from Kubernetes. It comes from before, from the 12 factor, which is a manifesto that was written by Heroku, I think more than 10 years ago at this point. And it's just a set of rules to create a cloud-ready application. Some of the rules are kind of simple, like use a version control system like Git, and some others are like this one, use some parameters like environment variables to inject configuration into your application. In this way, you can reuse the same code in different environments, and just by changing those environment variables, you get a different situation, like a staging environment for test and production environment. If you want to create a cron, it's basically the same as a deployment. So you still have a spec that describes a pod. Only two differences. You have obviously different rules. So you have a schedule that, well, it's the same as the cron tab. You have suspend, that it's basically the same as commenting out the cron in the cron tab with the hash. And how many pods you want to retain after a successful or a failure in the execution of the pod. Also, you don't have you have to add a command probably, because in a PHP application you will probably be reusing the same container that you use for PHP FPM, but you want to execute a different process. Okay, so with that you will probably be able to describe enough for your application, and this is what I got after I did all of that. So I have a CI pipeline that does all the tests, builds my Docker image, and then deploys, and then some stuff afterwards, but it's not important for us. So how I do the deployment? Well, when I started, I did it just that. I used kubectl, set image, and so I changed the image that was present in my deployment. Normally, I just changed the tag, so I was just publishing new version of my application. And with kubectl rollout status, I was watching the rollout of the new pods. So Kubernetes will change the pods for me without having to worry about blue-green deployment, availability, and stuff like that. Everything was done by Kubernetes. The only downside of doing that is that it doesn't scale well. Well, it doesn't scale in terms of development. As soon as I needed to change my application, add new environment variables or new deployments, it wasn't enough. It wasn't enough. So I needed a new tool. And the new tool is Helm. Helm is an open source project that lives under the Cloud Native Computing Foundation, or CNCF, which is the foundation that handles all the Kubernetes ecosystem of packages. And what Helm does is three different things. The first one is templating. So you can think about it as, I don't know, the twig for YAML. So basically you have a templating engine that allows you to avoid writing all that YAML by yourself by hand. Then it's also a package manager. So you can create a chart which is a collection of templates to distribute how your application is built. You can even find charts for a famous application like, I don't know, MySQL, GitLab, or Postgres, anything you want. You just take the chart, deploy it, and you have your application spin up inside a Kubernetes cluster. And then it's also a deployer. So it's the replacement for, I don't know, deployer, Capistrano, Capifony, stuff like that. A chart folder inside of your project looks like that. So you have, as you can see, the folder in here is highlighted by the plugin in PHP Storm. And then you have chart YAML, values YAML, and then a subfolder with all the templates that you need to have. There's a link to an example project that I used last year with another talk. The slide will be available at the end of the talk, so you can see by yourself. But I've pasted a little piece here and there of the examples to show you how this works. This is an example of a template. So as you can see, it looks a lot like Twig, but it's a Go templating engine. But the basics is still that one. So as PHP developers, you should know how powerful is a templating engine. PHP was born as a templating engine. Now it's more than that, obviously. And we have a templating engine inside PHP as packages. But still, that's the raw power that you have in hand. Basically, you can write down the structure of the needed YAML and just use a lot of placeholders to have parameters instead of writing that YAML over and over and over. So this is, for example, the template for the Ingress. So you have a few things that are written down and a few others that instead are written with parameters. Where those parameters came from the values YAML that I showed you before. Still a key value store, you just place a lot of your parameters in there, and it's a lot easier from now on to write down what you need and all the YAMLs. What I like to do with Helm is dump locally the result of the templates with something like that. This is a piece of a make file that I use on my projects. So I have Docker Compose to have a Helm container and avoid installing it inside my computer, and just call Helm template and the folder that contains the chart. Then I had -- output there to decide where the output will be written down. And I can use a lot of -- set to replace some values inside the values YAML. And this is useful. So in my example, I've added this value that changes the environment, for example. So I can have a target that produces the output for prod, another one for staging. And so I can basically review what Helm is producing for me, and I can review if I did some mistakes in the YAML. I even go a step further, and I commit those YAML inside my project with Git, so I can basically use git diff to see what I'm changing in the template each time. So I can, for example, refactor the templates and see if I'm not changing anything, like it was a unit test. And on the other side, I can even change stuff and see if the result of my changes on the templates are correct in the final YAML that it's produced. So this is a nice way to use Helm offline, basically, before deploying your application. When you need instead to deploy for real, you just use it inside your CI pipeline and call helm upgrade -- install. This means basically just that Helm will try to update the chart inside the cluster, and if it is not able to find that, it will just create from scratch. -- atomic instead, it's useful because it will try to deploy, and if anything goes wrong, it will do an automatic rollback to the previous version. So yay, free rollbacks, great. You don't even have to implement that. Helm will do that for you. Namespace, well, obviously you can namespace your resources inside your Kubernetes cluster, and this is pretty useful. At my job, for example, we have a couple of clusters that are used by multiple applications, and any application has its own namespace, so it's fully separated. Then you have -- set still here too, so you can pass anything you want from the CI to Helm to the deployment. And the basic example is the environment as before, or for example, the SHA of the commit that can be used, for example, to tag the images and to say, okay, this is the new version of what I'm deploying. Then you have to decide a name for your chart inside, well, for the installation of the chart inside the cluster. And then obviously the folder where the chart is. And with that, you basically have the same capability that you reach if you use deployer and a virtual server and stuff like that. It may seem complicated, but it's an abstraction. So like every abstraction, it has a little cost, a little cognitive cost, but the upside is that basically you can redeploy your application in a different Kubernetes cluster with a single click, basically. So you can change your hosting, or you can create a test environment in a matter of minutes, and that's fantastic. But you can even create more than one testing environment, and you can push this even further to create something that you cannot do with normal tools, which is, for example, per branch deploys. I will not have the time to describe this further, but this is a really nice thing that I did on the demo repository. Basically, I've changed my CI pipeline so that if I create a branch with a new feature, it can be deployed inside the cluster with a different installation of the same chart. So I just leveraged the parameters of my chart to say, okay, if I create a new branch, I want to have branchx.example.com to make it reachable. And so I'm able to show what I'm working on this branch to anyone else. I can give that to my QA people, to my product people, and have a shorted feedback cycle on my application, on my development. I no longer have to wait to the end of my work to have a feedback on what I'm doing. I can do that while I'm writing code. And it's really great. In this screenshot, you can see the environment page on GitLab. And basically, it has really a play and stop button that just trigger a step in your CI that creates the environment or deletes that in a single click. And that's fantastic because you can give access to that even to non-developers, and they can do that all by themselves. This is doable with something like that in GitLab CI or in the YAML that describes the CI inside GitLab. It's a bit more complicated than doing a single deployment because you have to be careful about your parameters. But still, if you did that just to have production and staging, doing for multiple other deployments, it's not so more complicated. And you just have to use helm delete when you want to shut down a new environment. And with that, I think I'm done. I've put a lot of links on the slides to go further. There's a similar talk that I did last year, the demo repository, another talk by Stefano from last year from phpday and stuff like that. So thank you. I think we have a few minutes for question, and please rate my talk on Joined-in and for all the other talks too. Thank you.
Thank you, Alessandro. As always, brilliant stuff about Kubernetes and all. So
too kind.
We do have one question from chat. Chris Holland asks, are you aware of the security pitfalls with Kubernetes, and what are the best practices to avoid them?
Okay, as I said, I'm not diving too much on the DevOps side of these things. Obviously, you have to care about a few things in security-wise. Well, I think you have to care about two categories of issues. The one is man access from the outside. So basically, you have to be strict about routing traffic. And that's kind of easy when you basically have to care about ingress and service, and that's all. You just have to not expose too many ports and too much traffic of your application. And this is something that you as a developer, you can care about. The other thing is caring about security from the inside. So be sure about what you're running inside your Kubernetes. So you have to be sure that all the components of the cluster is updated. And this is kind of simple in a managed cluster. So just have to be sure that you're up to date. The other thing that you can do is check what you're doing with your containers. So for example, at my job, my DevOps require me to avoid using root as a user when running a container. So avoid also using privileged ports. So no more port 80. I had to switch to, for example, 8080 and stuff like that, because they restricted the capabilities of my containers at the cluster level. So they said, okay, all the containers will not have a lot of capabilities because we are limiting them to avoid security issues. This is basically the same thing that you would have to do on a virtual machine. You will have to install security patches and shut down a lot of things and shut down additional services. It's not something overly complicated if you compare to the same thing that you would have to do on a normal virtual server. So yeah, it's a bit complicated, but it's not something on top of what you do in a normal situation. It's just something different that you can draw a parallel on. I hope I've answered the question fully.
All right, yeah, of course, this is a very broad topic, so feel free to ping Alessandro maybe and follow up with him and maybe spark an interesting discussion on Twitter. Which, by the way, the hashtag is #phpday, I think. So feel free to engage with that. And we have other questions. Max Sarione asks, is YAML the only available format to interact with the configuration?
Well, technically, no. When you use kubectl, you can get and set using YAML and JSON too. YAML is probably the easiest to write by hand, and as I said, it's still validated, so it's easy to avoid writing the wrong stuff, because basically when you try to do kubectl apply -f the file, it will be rejected by the cluster if you write something wrong. And as I said, I also use that procedure of committing the YAMLs just to review them and be sure that I'm not writing the wrong stuff. You can use JSON if you prefer, but obviously it's not so easy to be read from the screen as a human, let's say.
Right. An interesting question from Daniel is, how big is the biggest cluster you have ever worked with in production, and in terms of number of nodes, pods, etc., and on which?
I don't know. And this is a nice thing. Basically, I don't have to care because as a developer, well, obviously I work in a big IT department, so we have split in different teams and we have many projects and we have 3 or 4 DevOps dedicated to the whole department. So I basically don't have to care. I don't have to know how many worker nodes there are there. I think that the biggest was 16, or maybe we scaled up to 25 in a particular moment because we needed to handle some workloads. Which were temporary. We were doing a batch import, but still, I don't have to care. I just have to say, okay, I need to scale to 4, 6, 10 pods that requires each some amount of resources, CPU and memory, basically. And I just have to tell that to my DevOps colleagues and say, okay, that's what I need. That's all. And this is I think this is the real cloud for developers, because I'm using the prod environment as a service, and I don't have to care about Linux distros, about security patches. I just know that I have a couple of worker nodes with enough resources for me, and that's all.
All right. Very nice.
Any more questions?
So Stefano Angaran asks a very broad question. So let's see if we can tackle it in a bit of a kind of a generic way. How would you go about troubleshooting production issues? Like, what's the approach to fix critical bugs, for example?
You mean bugs in the code, in the application, probably?
I guess so.
If you have enough privileges on the cluster, you can basically do the same as Docker exec, so open a shell inside the pod, but it's not so secure, obviously. So it's the last resource if you need it, but otherwise it's better if you try to instrument your code differently. So I've discovered that doing that differently, it's probably better because you will get feedback early, like having some tool like Sentry for error reporting. Well, obviously biased in that because I'm a maintainer of Sentry PHP library. So yeah, that's why I'm using it. Having good logs, and in a Kubernetes cluster, you normally just need to log to standard output and the cluster will just grab them for you. And you can maybe put an elk stack on top of that if you want, or use, if you're on a public managed cluster, you will get that for free, like, well, free, kind of free. You still have to pay for that. I think AWS has CloudWatch, if I'm not mistaken. It's the same. It's the same. You can use that on a virtual host machine or a Kubernetes cluster. You still get the logs out of your application. And that's all. In some cases, I did the exact thing, but it's really low level and maybe it's not such a best practice, but it's the last resort if you need it.
All right. Last question we have is, what about the development environment? For instance, with file synchronization or something like that?
Well, still following the 12 factor, you shouldn't use file synchronization. It's not so good in the same way as you would resort to using NFS on virtual hosts. There are ways to do that. There are resources that you can use inside a Kubernetes cluster to do that and have a network file system. But obviously, this is not so performant because you have to go to the network level. So it's better if you use different approaches for this kind of stuff. At work, for example, we are migrating a couple of older applications to Kubernetes, and they just switch to using S3 to store information and to store files. It's a better approach because then you don't have to care on which worker nodes you are working or on which server farm or where are you. You're just using a remote service to store files and retrieve them in a nice way. In PHP, we have nice libraries like Fly System to do that. So I think it's better to migrate to something like that.
All right. I think we are done with the Q&A. So I would just greet you. We are going to see you in a while because, as you people may know, I'm gonna leave my duties of MC and to the hands of Alessandro here. So he's going to take my place from 4 p.m. I think, because I will need to get some work done for today. But yeah, I will still host the next speaker, and then you will be greeted by Alessandro. So see you later, Alessandro, and thanks for your talk.
Thank you.